Okay, so version 5.0 of the Tycho software has recently been released. I've been working on this for some time now, so it's exciting to finally have this in a releasable state. And so if you're curious to know what the new features and enhancements are, I put together this video to kind of go over what to expect, as well as a demonstration of some of these features. So to get started, the first item here that I think everyone will benefit from is the improvement in contrast adjustment. So not all images are impacted by this, but there are some that you might have noticed in the previous version where you tried to improve the contrast of an object, but it just didn't really seem to improve much at all. In fact, it might have even made it worse. So version 5 now improves upon that, so the ability to recognize fainter objects is now much improved. The next item here is the concept of repositories. So this provides a way to organize objects and observations, as well as a way to pull objects from the Minor Planet Center website. For example, the NEO confirmation page, as well as recently confirmed, they can have their own separate repositories. And that kind of ties in with the next item, which is this object linker tool. So this provides a way to determine if there are any links that exist between objects in different repositories. So for example, maybe you had one night of observations followed up by another night of that same field. It provides a way to establish what links, if any, might exist between those two nights of objects. Finally, the other item here is the ability to generate statistics on an image, and so I'll go over that as well in a demo. So to go ahead and get started, here we have the demonstration. Okay, so as far as contrast adjustment is concerned, this is the old version, and as you can see, the adjustment here does not really make the object any more recognizable, and so this is a problem if you're trying to detect a faint object. Now here's the new version, and as you can see, the contrast adjustment is much nicer. You can really start to recognize the object, and it stands out a lot better. Now another nice feature in this version is that it will always attempt to display speed and position angle, provided that the observation in question has movement information available. So in contrast, the old version would require you to select 2 or more observations in order to compute this information, but this new version, you only have to have 1 observation selected, and as long as it has movement information, then it is able to display speed and position angle. Okay, now another new feature is the concept of repositories. So this is where you can store observations to a directory that has been designated as a repository. Another use for this is if you download observations from Minor Planet Center, you can store them in certain repositories associated with their particular designation, if you will. So NeoCP objects have their own repository, recently confirmed objects have their own. So for example, if we wanted to, we could pull an update for objects that are on NeoCP, and that stands for Neo confirmation page, as well as objects that are from the recently confirmed page. Now the purpose behind this is if you have a potential new discovery, you might want to know if it matches up with one of these objects that have potentially been found by another observatory. And so Neo confirmation page is one resource, and recently confirmed is also another one. So this gives you a way to see if there is a match between your candidate discovery and something that somebody else might have also just recently discovered as well. So what we've just done here is updated the NeoCP and recently confirmed repositories. And so for example, these are all the items, all the objects on recently confirmed, going back to the past 100 or so. And so these are all objects that you could then match up against for your recently confirmed candidate discovery. Likewise, the same is for NeoCP as well. And so just as an exercise, we can try that out. Okay, so for this exercise, I'm going to pretend as though I have some new discovery, some candidate discovery, and the goal is to determine if it is a match with some other object that somebody else might have already encountered. Typically, you would use the NP checker tool. That is a tool on the Minor Planet Center website, but typically an object that's on the NEO confirmation page or even recently confirmed, the NP checker tool will not search those kind of objects. And so this is sort of a supplement to the NP checker tool in that context. So it's another resource, it's another way to help determine if your potential discovery is new or not. So what I'm going to do here for this exercise is I'm actually going to take an existing object that is on the NEO confirmation page. Here's one that has 10 observations, and I'm actually just going to take these last 3 observations and then save the remaining 7 back into the repository. So what this does is it takes that object, and again we had 10 observations, now we have 7. And then I'm going to take the 3 observations that I selected earlier, and I'm also going to, just for this example, I'm going to change their designation as well. So just to help solidify what's going on here. And then I'm going to save these observations as a new object in its own repository. So we could save it to some existing repository, or just for this example, we could create a new repository, and then we'll save these observations as a new object in that directory. So as you can see, we now have an object with 3 observations on it, and we want to determine if it matches up with one of these other objects. So to do that, we go to Tools, Identify Linkages, and you'll notice that there are 2 different sets here, 2 different search directories. So set A and set B. Typically, set A will be objects that have several observations on them, that, so for example, these will be the NeoCP recently confirmed. And then set B will be an object, or even multiple objects that you want to compare against. So in this case, this would be our example repository that has, in this particular case, 1 object, although it could have more. It could have multiple objects in it if we wanted to. So what's going to happen is it's going to take all these objects here, over 130, and for each one, generate a candidate link. And what it's actually doing, so I'm just going to go ahead and click Start, is it's going to invoke the find orb software for each possible link and evaluate the result. And so it's actually doing that in the background, and then it creates a list and sorts it by likelihood that it's a good link. And so we'll go ahead and give this a moment to run, and then we'll take a look at the results. Okay, so here are the results, and as you can see, it found a good link between this object A over here and object B over here, which in other words is to say that the new confirmation page object that had 7 observations on it that we were looking at earlier is in fact a good link with the 3 observations that we created just a moment ago. And so if we wanted to, we could look at these combined observations and view it in find orb software and so forth. So it was able to establish that there is in fact a link between this quote-unquote discovery that we're pretending that we have made versus an object that is on the NEO confirmation page website. And then it also displays other possible links, but the residuals are so high on those that there would not at all be a likely link. So if we wanted to, we could just display 1 link per object. But in any case, this demonstrates the ability to link possible objects with each other, and this can also be used not just with NEO confirmation page or the recently confirmed repositories, but other repositories as well that you've created. Maybe you have 1 night of observations in a particular field, and then you revisited that exact same field, and you wanted to see if there were linkages between those two nights of objects that you created. And so that would be another way to do it, is through this tool here. Okay, another nice feature is the ability to convert from the new ADES format back to the MPC 1992 format. The reason you would want to do this is that some of the tools on the Minor Planet Center website are not quite able to take in observations that are in the new ADES format. So for example, the MP checker tool, if I were to paste in observations in that new format, it's just going to tell me that there's an error, check the formatting, and so it doesn't like the new ADES format. So in comparison, what we can do is we can go to Tools, Existing Observations, and paste the observations into this window, and then choose Convert from ADES to MPC 1992. And so as you can see, the observations are now back into the MPC 1992 format, which enables us to then make use of the MP checker tool. And so if we give it a moment here, it's going to run through and process these observations. You'll notice it has not complained about the formatting. So here in a moment it will come back with the results. And as expected, it found a match. And so again, that's a great way to, if someone gives you observations in the new format, typically you won't be able to use them directly in that format with a lot of the tools on the Minor Planet Center website. So having the ability to convert is a nice feature. Okay, so another new feature in version 5 is the ability to generate statistics on an image. The image could either be that of a single exposure or a stack of exposures, but the main consideration is that the stars in the image should not have any streak to them. So in this example, we are tracking an object that has motion, and as a result, the stars have streak to them. So to correct this, we can instead choose the zero motion stack, or we could have simply loaded the images into the software without having performed any tracking to begin with. But either way, the image again could either be a single exposure or a stack, and the stars should not have any streak to them. So we're at the image viewer, and we can go to File, Generate Stats for Current Image, and it will prompt us for the maximum number of stars for which to generate statistics. So the way it works is it's going to go through the star catalog, and it will choose a random sampling of stars in that catalog for which it generates the statistics. So I'm going to go ahead and click the Start button, and as you can see, it will take a while to go through all these 2,000 stars, so we'll go ahead and give it a moment to process the information and then see what results it has for us. Okay, so here are the results. As you can see, there are a lot of columns to work with here, but basically each star is shown as its own separate row, and so if I were to click on a row, that will take me to the associated star. And so here we have the X and Y position of the star, followed by the true right ascension and declination as it was taken from the star catalog. Next we have the computed right ascension and declination as it was measured from the software itself. And then next we have the error in measurement, so the error between the true and the computed. And finally we have the max residual, which takes the maximum of the absolute value of these two error values and then displays that as its own column. And so that's for position of the star. For the photometry information, we have the true magnitude, we have the computed magnitude, and then we have the delta magnitude. And so you could also sort the list by either column that you wanted to do so on. And so for example, here's a star that has very high error in measurement, but the reason for that is it's very saturated. All the pixels are saturated, and as a result it is difficult to compute a reliable centroid of that star. Conversely, a star that has good measurement will have not very much of any saturation, as well as a decent signal-to-noise ratio. So you could also generate a plot of some of these fields So here's a plot of max residual versus magnitude. So we have magnitude on the x-axis and max residual on the y. And this gives some idea. You would expect this relationship that as the star becomes fainter, the max residual tends to increase, and that's because the star now has less signal-to-noise ratio. And this also provides a way to evaluate potentially the limiting magnitude of the image. So the software says that it has a limiting magnitude, in this case, of 20.6. So another thing we could do is simply export to a CSV file. And so this allows us to open up these parameters, these columns, into another spreadsheet. Then we could generate charts and graphs in this fashion as well. That wraps it up for this demonstration. Thanks for watching, and see you next time.